All right, we're going to go over the entire experimental design standard all at once, but using an example of an experiment. So we'll be going over an experiment, how to set it up, and using it to explain what are all of these different learning objectives for the experimental standard. Starting with the very first learning objective, it says, I can identify and adjust an independent variable. So that's the key word there, independent variable. Got to know what that means. The second one says, I can plan for how a dependent variable will be measured. So when you're talking about an experiment, we have independent variable, dependent variable, and all other variables, which we're going to call controlled variables. This experiment is going to be based off of a pendulum. The question that we're going to be asking is, how does the period of a pendulum, so the period being how long it takes for a pendulum to swing back and forth, change with a change in pendulum length? We need to identify what the independent and dependent variables are. So first off, the independent variable is what you're purposely changing, and the dependent variable is what you're measuring because of that change. So here, we're changing pendulum length. So this right here is the independent variable, the pendulum length. And then the period of a pendulum is what we are observing because we've changed the length. So we change the length, and then we're going to measure how long does the period last. Therefore, it is the dependent variable since we are measuring it because of a change in the independent variable. So going back to the experimental design, we need to identify and adjust the independent variable. So we need to be able to identify how we're going to adjust the independent variable. And then I can plan for how the dependent variable will be measured. We've identified what's the independent and dependent, but we haven't talked about how are we going to change that. We'll go over hypothesis in a moment, but let's just go down to the procedure. So here's going to be the set of procedures. We're going to set up a pendulum with an initial length of 0.2 meters. This is a diagram of the pendulum setup. We're going to offset the pendulum, so just take it from here and lift it over, only to about 10 degrees. And I say about, meaning that wasn't very precise. And then we're going to release, and with a stopwatch, time how long it takes. This timing how long it takes, that is measuring our dependent variable. So when it talks about how are we planning to measure our dependent variable, we're planning to measure it by using a stopwatch and just start and stop the stopwatch over the time it takes to swing one way and then back to the other. Once it gets back to there, we stop the stopwatch. And I have a comment here. It's not that great. This could be a better one. We'll talk about how to refine this and make it even better later. And then we're going to increase the length of the pendulum by 0.2 meters and repeat the trial. So this right here, increase the length by a specific amount, that is how we're changing the independent variable. So we've identified how we're going to adjust the independent variable. We're going to increase by 0.2 meters every trial. And then we also planned how we were going to measure the dependent variable. So those two right there are covered. This is the pendulum setup. According to procedure 1, it should be set 0.2 meters from the pivot point, which measuring the center of mass of this is currently set up at 0.2 meters. And according to procedure 1, after setting it up like this, the next step would be to pull this back about 10 degrees, release it, and time how long it takes for it to come back. It took the pendulum about this long to do one full oscillation, and that number represents its period. Let's talk about the third learning objective. I can make choices in the planning to minimize the impact of other variables. So the idea of a scientific experiment is you are just changing one variable and seeing how it affects another. You don't want two things changing at the same time because you won't know whether the change that you measured was due to one of the variables or the other. So we want the only thing changing for each of our trials to be the length of this pendulum, which means each trial, we're going to need to offset it by the same amount, that 10 degrees. Also, each trial, we're going to need to have the same mass of weight and everything else the same. The same material for the string, the same method for starting and stopping the stopwatch, even the same person doing the starting and stopping of the stopwatch, because each person's reaction time is going to be different. We're going to talk about reaction time too later. So that's what that means by we're going to make choices to minimize other variables. So we're going to control our other variables. So those are called controlled variables. The fourth one, I'm going to consider the limitations of my measuring devices and make decisions to increase the precision of my measurements. The idea behind this one is we're going to try to make the most precise measurements possible. This comes back to the note that I made that this method of starting and stopping the stopwatch isn't the most precise. Instead of starting and stopping the stopwatch for one cycle of this, we could extend that time and do it for 10 cycles. So here's our second set of procedures. This is going to be refined and more precise. First off, we notice in the very first step, we specify that we're going to measure the length of this from the center of mass of the hanging object. We're being very specific. A good science procedure, a good science experiment is going to be very specific.
Specific.
On each of the steps. Here's the note I made earlier about how we're going to do the timing of this. Instead of just for one oscillation, we're going to have it complete 10 oscillations and then stop the stopwatch after the 10th oscillation. We got this number just by measuring one oscillation. And that is a very imprecise method. Because think about the human reaction rate. Humans have a pause between seeing something and then reacting. So seeing something and then pressing the button to stop the stopwatch, for example. Let's look at a breakdown of how much of a percentage is this reaction rate out of how long it took. The human reaction rate is not perfect. Let's say it takes 1/4 of a second for us to see something and then touch a button. So stop the stopwatch. If we only measure this once, let's say the period was 1.25 seconds. We're just making up the number here. What if it was 1.25 seconds? That would mean that this 0.25 seconds reaction time for us stopping it represents 20% of the total time. That means we could have been 20%, so that means we could have been 20% late or 20% early. We measured the period was 1.25, but this could have easily been 1.00 all the way to 1.50 because our reaction time was 0.25 seconds. So we're not sure, maybe it was too early, maybe it was too late. This uncertainty is a high percentage. But what if instead we measured the period for 10 oscillations and we found the period of 10 oscillations was 12.5 seconds? Our reaction time did not scale with the number of oscillations. It's still the same base 0.25 seconds reaction time, no matter if we're doing it for 10 oscillations or one oscillation. Now, 0.25 seconds out of 12.5 seconds, that's only a 2% uncertainty. So this number right here can only be off by about 2%. We've changed our potential error from 20% to 2% just by changing the fact that instead of measuring once after one period, we measured after 10 periods. And then, of course, took that time and divided by 10. We still have to take the 10 oscillations and divide by 10 so we can get how long per oscillation. This is the essence of learning objective 4 here. We are thinking about how are we measuring our values? How are we getting these values? What tools are we using? And how precise are those tools? And is there anything we can do to increase the precision? Is there anything we can do to make our values more precise? Fifth learning objective is about making a hypothesis. So right here we have a hypothesis for this experiment. If we set up the multiple pendulum with varying lengths, so if we set up one pendulum with one length and one pendulum with another length, then we will see that the period is proportional to the square root of the length of the pendulum. I want to point out also that in learning objective 5, specifically, this is mentioning that the hypothesis is going to state what is happening to a dependent variable when an independent variable is manipulated. We're saying that we expect something to happen to the period because we've changed, increased, or decreased the length of the pendulum. So inside your hypothesis, I should be able to recognize what your independent variable is and what your dependent variable is. So a hypothesis is never a random guess. Scientists just don't randomly guess things. There's a reason for why they make the hypothesis the way they do. So there's a reason that we're saying that the period is going to be proportional to the square root of the length of the pendulum. And that's because many other scientists have done this, and they've found that this equation right here describes the period of a pendulum, t being the period. So this equation is saying that the period is going to equal 2 pi times the square root of the length of the pendulum divided by some constant g. Now this g right here and pi, those are both constants. These constants don't change. That's what it means to be a constant. The only thing that changes then is the length. Proportionality just means that as length increases, how much does the period increase? So we can ignore all the other variables and just say that the period is proportional, and this is the symbol for proportionality, proportional to the square root of L. Everything else is staying the same, so the only thing that's changing is the length, so it is proportional to the square root of L. Learning objectives 6 and 7 are less about science experiments and more about engineering problems. So instead of using the scientific method, we are using the engineering design challenge or the engineering design process. So we'll go over that in a different example in another video.